Hi, we're Group 7. My name's Chris.
I'm Bryson.
I'm Nick.
And I'm Adam, and this is our solar charging station for e-bike. Nick and I are responsible for the locking and user interface systems and temperature regulation system.
These systems include a self-locking mechanism. In addition, the unlocking mechanism randomly generates a code and sends it to the user's phone via Bluetooth. The user then inputs this code into the keypad, which unlocks the bike.
And also on top of that, we have the temperature regulation system, which basically utilizes a fan to keep the temperature of the system inside at a healthy rate.
So now we're going to demonstrate the self-locking aspect of the bike rack. So as you can see here, all you have to do is slide the bike into the unit. It automatically locks itself. You cannot remove it, and the bike is secure.
Now for the unlocking part. So first step is the system is going to send the user a randomized code to unlock the bike.
As you can see here, the code is 7594.
All right, so now looking at the keypad, we're gonna just all right, so first star 7594. As you heard, the solenoid has just unlocked. So now we take the bike out, it's unlocked, and now since the system gave the user some time to take the bike out, it will lock right now. So in this part, we are demonstrating the temperature regulating system of this project.
So we set the internal temperature threshold to be about 22 degrees Celsius. So as soon as the internal temperature of the bike rack goes above that limit, the fan will kick on to cool down the system. So as you can see here from our remote monitoring system, the internal temperature is 23 degrees. So this has turned on the fan, as you can see down here. And the fan will remain on until the internal temperature of the bike rack has been back down to the threshold.
Chris and I were responsible for the power transfer system. This included the charging of both batteries and the maintenance of battery health. The system is comprised of the solar panel, followed by a buck converter circuit to step down the voltage to roughly 14.5 volts to charge our energy storage battery.
From there, our energy storage battery operates at a slightly higher voltage than our simulated e-bike battery. So that allows us to transfer charge between the two batteries. A couple safeties that we have in place are that we have two charge controllers to ensure that neither battery is ever overcharged or over discharged. And we have a logic system in place which utilizes two relays to ensure that the intermediate battery is never simultaneously charging and discharging.
Here we're going to be demonstrating the charging mechanism of the bike rack. Normally these components are housed inside the bike rack unit, however we brought them out just for the purpose of the demonstration. So as you can see here, we have the solar charge controllers, and then over here we have the battery that simulates the energy storage battery. Here is going to be the battery that simulates the e-bike battery, and then lastly we have the laptop that will show the serial monitor data and show the voltage and current readings from the solar panel and from our batteries.
Okay, so now we're going to outline what's going to happen in our demonstration. So we're going to start with this lead disconnected, simulating that the e-bike has not been plugged in and currently the solar panel is only charging the energy storage system. We're going to show some of the readings here of the voltages and currents that we're getting between all of the components. Now we have to remember here that currently both of these batteries are fully charged. So the solar charge controllers are not going to allow any current to pass through, so our current readings are going to be very low. Then, after that is run for a cycle or two, we're going to connect this lead here, simulating that the user has plugged in their e-bike to the system. Then what's going to happen is the software is going to recognize via a voltage sensor that the battery has been connected. The relays will switch, and we'll have a brief period where the software is going to determine whether or not this battery is charging. If this battery is not charging, i.e. if it's full, which is what's going to happen in our case, then the relays will switch back and no charge will be transferred between these two batteries. We will continue with just the solar panel charging the storage system. So as we just discussed, the first part of this demo is going to show when the e-bike has not yet been connected to the system. So right now, there's no e-bike currently charging. If we zoom in on our readings here, we see that we're getting around 20 volts coming in from the solar panel and no current transfer between the batteries. This is because the storage battery is fully charged and the e-bike battery is not yet connected. Now, when we connect the last lead, simulating the user plugging in their e-bike to the system, and we zoom back in on the readings, we now have the around 12 to 13 volts showing up from the second battery. So now what's happening internally is the system runs a quick test to determine whether or not this battery is fully charged. In this case, it is. So we're going to have both systems conducting for a brief period of time while that test occurs. Once we determine that this battery is fully charged and that it's not taking any more current from the storage battery, the relay between the two batteries opens and we continue only conducting between the solar panel and the storage system.
We want to thank you for watching our demonstration, and we'll be more than happy to answer any questions on presentation day.